This is Maurizio, editor-in-chief of Power Electronics News, and today I am here at PCIM showing in Nuremberg, and I have the pleasure to be here with John Tucker, Power Market Segment Leader at Tektronix. Hi John, thank
Hi,
you for
Maurizio.
being here.
Yeah, you're quite welcome. Thank you for inviting me.
How is it going? Everything is good?
Yeah,
Everything
very
is
good.
under control?
PCIM has been a very exciting event this year, talking to many people that I know and really getting a better understanding of what's happening in the industry and where this is going.
Yeah, indeed. PCIM, so what's new from Tektronix? Tell us more.
Great question. So this year we're actually introducing a brand new isolated current probe, which I call it kind of the sibling of our isolated voltage probe that we've had for quite some time. This is a probe technology that many customers have been asking us for. It was not just about measuring voltage, but they also want to be able to measure high current at the same time. So this new current probe really was launched mainly on customer feedback. We had a lot of our customers were actually involved in the development to make sure it would work in their applications. So we're very excited to have both an isolated voltage and now an isolated current probing for really learning more about what's happening to their devices and certainly their applications which are putting them on.
So a topic that I like talking and writing is wide-bandgap, as you know, silicon carbide and gallium nitride. So they are evolving, they are powering everything from EV chargers to solar inverter. So let's talk about reliability testing and qualification protocols. So how so they are evolving? What are the emerging trends? Reliability testing protocols with wide-bandgap and silicon carbide. How they are evolving also to better capture the real-world stressors like high DVDT, avalanche events. So what about?
Yeah,
From your point of view, Tektronix testing company.
Yes, that's a great question, and certainly we are really in the middle of being able to do a lot of those tests and to enable our customers to be able to do that. I think what's very, very important, and it's something I actually heard a lot during the event here, reliability is becoming even more and more important. Why? Because in a lot of these applications to which wide bandgap technology like silicon carbide and gallium nitride are going into, they have to last a long time. Think about the average owner of an automobile. You want to hold on to that automobile for like 10 to 15 years. So if you think about it in an EV, people want that EV to keep on going for 10 to 15 years, which really means that these devices have to last. They have to work. And given that a lot of these devices are also going into mission critical applications. Think about these new eVTOLs, these electric vertical takeoff and landing vehicles that will be flying around the skies pretty soon, or aerospace applications, or even industrial energy. The reliability of these devices is critical, so you're going to see a lot more in the way of long-term life testing being done. They'll be doing accelerated testing on those devices to see what happens. These devices have to operate at different operating temperatures and environments anywhere in the world, so they're going to be testing these in different conditions over the long term. So our capabilities, whether it's in power supplies to power up these devices, to actually measuring double pulse testing, or doing power integrity, power analysis on these devices are very, very important. And we're kind of right in the middle of that to help these customers really get to the information and the data they need to collect in order for these devices to last a long time.
Let's talk about industrial fields, industrial environments. So they are becoming more electrified, digitalized, connected with smart solutions in terms of robotics, running on wide bandgap. So wide bandgap based solutions such as silicon carbide and gallium nitride, as we mentioned. But with that, we are also seeing in increasing in terms of complexity for the system. Just the increasing of topologies, the increasing of using wide bandgap, but also running different challenges in terms of power quality, for example, including harmonics, EMI, and so on. So how do power quality testing, EMI, mitigation strategies should evolve to meet the evolution of industry, also considering factories moving in high voltage DC infrastructure?
Sure, that's a great question. And it's funny when I think about that, I think about like data centers.
Yeah,
I actually have heard stories where people are saying that the data center is the next generation of a manufacturing system. Okay, a data center itself is manufacturing information. So when you think about power quality, I have to relate to this based upon a story I heard just recently at a major energy summit in Washington, D.C., that the power quality of a data center is essential. And you have to be very, very concerned, especially when we think about the grid. When a data center actually goes from a normal operation mode to a learning mode, that's an instantaneous, almost instantaneous jump from megawatt to gigawatt of power consumption. Is the grid stable enough and capable enough to make those changes? So power quality is very important. Certainly EMI is important. I think about EMI, especially like in an airplane. You can't have that, especially when you have a lot of fly-by-wire and digital controlling capabilities of our next generation of aircraft, which are going to use wide-bandgap technology likely. So EMI is becoming very important. We have the capability in our portfolio of products to actually measure a lot of that. So again, we're helping really to enable customers to look at the power quality, do power distribution network analysis, as well as measure EMI to ensure that these designs are going to work and it's not going to cause problems down the road, especially as we go from a manufacturing that's really been based upon AC for so many years now to DC.
And talking about grid, so let's talk about energy storage, energy storage systems. So they are important to enabling the next transition to renewable energies by balancing supply and demand. So what about testing protocol for energy storage? Also consider that when you are integrating different chemistry in terms of battery, such as solid state, that is going to have a great market. Which is your comment?
Sure. So with respect to batteries, there's all sorts of different chemistries that are involved in batteries that are coming out and yet to come out. And these batteries are going to behave differently depending upon the operating condition, whether it's in a high temperature, a cold temperature. So we're going to have to understand how those batteries operate in those different conditions. And the same thing really holds true if those batteries are going like into a battery energy storage system that's supporting, let's say, a microgrid or even, let's say, a major solar energy production area that could be used eventually on the grid. Again, how are those batteries going to operate in different climates, different temperatures? Yeah, they could be in climate-controlled environments, but I look back at what just recently happened, for example, just in Spain, just a couple days ago. So it's raising a lot of very critical questions about do we have the right protocols in place, especially for battery energy storage and tied into the grid or tied into solar systems. We got to make sure they work. And I just saw a statistic just the other day too, with respect to different forms of renewable energy, where solar now is actually producing more electricity than wind energy is. So you're going to see more solar energy farms. They're going to be supported with battery backup systems. They'll be part of microgrids. All have to work together and can't fail either. Got to have that power.
Yeah, indeed. So John, in conclusion, grid, energy storage, renewable energy sources. We have solar, wind, but we have also nuclear.
Right.
Nuclear, we should talk fission and fusion. Fusion probably the next generation. I don't know when. So, which is your comment? Should we invest more in one source or no? Everything solar is most important, for example. Depends on the country, of course. So, which is your comment?
That's a great question. I think what we're going to see in the next 5 to 10 years is a really diverse set of choices, of a mix of what will be used. So there are some regions of the world, like where I live, I don't get sunlight all the time. It tends to snow and rain a lot. So you're going to see solar used in very unique areas of the world where they're going to get a lot of solar capability. Wind is still going to be around for a while, though. But I think what's very interesting is the future of nuclear power, where there's all these new designs for nuclear reactors. Micro-reactors. In fact, again, at this energy conference I attended just recently, they were talking about the ability to put a micro-reactor on the back of a truck. You'll take that micro-reactor to the customer site. It'll run for whatever the designated period is. And then when it needs to be refueled, they'll take it back, they'll put it on the truck, take it back to the company, and they'll be able to refuel it. So I think you're going to see more in the way of these microreactors, especially at like data centers. We've heard stories like Microsoft Google, Amazon
Yeah.
have put in, at least I know in the United States, are putting in licenses for nuclear reactors to supplement the demand that they have. But I think the next really exciting engineering marvel that will happen, hopefully in our lifetime, is nuclear fusion. And this is really exciting. That is the power of the sun. And there's so many companies around the world that are actually working on it. Governments are investing in it. It will likely be one of the most amazing engineering feats, hopefully in our lifetime, to be able to harness the power of the sun that could provide just unlimited amounts of energy to us, and it's so clean. And I would argue that even power semiconductor, batteries will all be involved some way or form in this next generation of nuclear power as well.
Yeah, so bringing the power of sun on our planet is a big challenge.
It
Probably.
really is, but it's exciting, and it's going
Absolutely.
to happen in the next 5 to 10 years before you actually start seeing companies actually having net power, and then ultimately they'll be able to have more power.
Yeah, but when you have the power, you have to share with the grid. In this case.
Exactly.
This is another step.
That will be a challenge in its own. Is how do you get these fusion plants onto the grid, and hopefully by that time the grid will be updated enough to
and
support
testing
that.
protocol as well.
And testing protocols by different standards bodies around the world will have to be involved, no doubt.
Thank you, John. Thanks
So
a lot
thank
for
you.
your time.
Thank you very
And
much.
Have a good day at PCIM and see you next.
Thank you very much.
Thanks for watching. Thank you.